This argument is inspired by Pyrrho. These vertical lines with arrows represent gravity towards the surface of the Earth. Two balls, two masses. If this mass is released to fall vertically with gravity, at the same time this mass is propelled off of this ledge with any given velocity, it's a known fact in physics that it will hit the ground at the same time this one hits the ground. They land at the same time. What can we deduce from this fact? If we consider this object mass, it must prove that moving perpendicular to the direction of gravity at any velocity can make no difference to the force collected or the mass being affected by the gravity. If it did, then it would alter the time that it would hit the ground. There would be a difference to the one that is dropped vertically. If it is now argued that, yes, but they are in gravity, if they are falling in gravity at the same time, therefore there is no effect. That is exactly the proof that moving tangentially to the direction of gravity at any velocity makes no difference. There is no difference to the force on this object. If there were, if it was collecting less force, it would take longer to fall to the ground, and it would fall after the vertically dropped mass. The very fact that they take the same time is proof that there is no effect by moving a distance or a time in a perpendicular direction to gravity. Velocity or time must be irrelevant. Comments, please.